Hey guys, welcome into the next piece in our greatest common factor things. Yesterday, hopefully that video introduced you to what a greatest common factor was if you didn't know what it was. And you were able to, if you were given a couple of terms, be able to figure out what the GCF was. Now today we take it a step further before we get to this idea of what it means to factor. Keep in mind, yesterday I sort of showed you where this is headed. This is totally headed in, we want to be able to figure out if something was distributed, what was that piece that was distributed, and what were the two things that were multiplied. That's ultimately going to be our goal. And again, that might not make a lot of sense yet. It will start to tomorrow. But today we're going to take it one step further. It's not much different than what you did yesterday, except that I'm going to show you an entire polynomial and ask you to find the GCF of an entire expression. Now, let me get this video of myself out of here. You don't want to see that. Okay, so, and we'll come back to this idea when we want to factor. We always want to look for greatest common factor first, but we're not factoring yet, so let's not worry about that. Let's take a step into what I asked you to do, a step further, or one step further than what I asked you to do yesterday. Okay. Take a look at this. This thing here would be considered a polynomial. This would be considered, if you wanted to really be technical, a binomial because it's got two terms, one here and one here. Now, what I want us to do today is find the GCF of this polynomial. Now, again, what does that mean? Well, what I want you to do is I want you to look at these two terms separately, and like you did yesterday, find the greatest common factor between those two. Now, the reality is they are all one polynomial, but I want you to separate them and find the GCF of these two terms. Okay. Well, they both have a number that divides evenly into them. The biggest one is 3. They both have a variable in common. They both have x's. The one with the lowest exponent is x squared, so 3x squared is considered the GCF of this polynomial. That's all there is to it. So you're just taking a polynomial and separating it into its terms and find the GCF of all of those. So once you do that step, it is kind of like what you did yesterday. All right, let's take a look at this next one. All right, so this next one has 3 terms to it. If it helps, and I don't know if it does or not, but you can do what I was doing and just put circles around them so you know what the 3 of them are. And we want to find the GCF of these 3 terms. Okay, well, they do have a number that divides in all of them. The biggest one is 2. They all have a variable in common. They all have an x. The lowest exponent is this one. That's x at a first. Okay, so we say 2x is our GCF. Done. That's a little bit more fun because there's 3 terms to it. So at least I find that fun. Maybe you don't. All right. Last one, and then that's it. Quick video today. Okay, take a look at this last one. Oh, yep. I gave you 2 different variables in it. No big deal. If you want, again, to circle them so that you separate them, you can do that. All right. Do 9 and 12 have a number that divides even into both of them? Yep, it's 3. They both have an x. One is x squared, one is x. Take the one with the lower exponent, so x. They both have a y. One is y squared, one is y to the 5th. So we take the one with the lower exponent, y squared. So 3y squared is my GCF. Little hint, you're going to find out tomorrow that means this was the piece that was distributed to something else to give you this whole thing. All right, but let me not get too deep. That's it for today's video. Tonight, you'll practice that for your homework. You're going to go ahead and find the GCF of a polynomial. Good luck.